Okay, so a circuit is given. Part A says use Kirchhoff's law and Ohm's law to find the voltage V naught as indicated here. Okay, and then we also need to find the power of the different elements. Okay, so let's start with V naught. And okay, so this circuit, as you can see, there's an independent voltage source, but there's a dependent voltage source as well. So there's a voltage source which depends on current, which is this IS. Okay, so therefore to find VO somehow in this loop, I need to know this voltage, and that voltage depends on IS. So let's first find IS, and that's just a simple circuit. So 10 volt is here, the whole thing is 10 volt. So basically this is 10 volt. So for this 6 ohm resistor, the voltage is 10 volts. So IS is equal to V over R, which is 10 volts divided by 6 ohm, which is 5 over 3 amp. Okay, so IS is 5 over 3 amp. And now this dependent voltage source is 3 times IS. So 3 times 5. So here I would say 3 times IS, which is 5 over 3, which is 5 volts. Remember, it's a voltage source, so therefore here we have 5. Okay. And then 5 volts, so the question was what is VO? And now hopefully everybody sees that. This is just the voltage divider, right? So I know the voltage here. There are 2 resistors. And then so V naught, VO is 3 divided 3 plus 2 times 5 volts. So 3 over 5 times 5 is equal to 3 volts. So therefore VO is 3. Yeah. Now on part B, we need to find the power. So therefore, let's just solve other parts of the circuit as well. So what is the voltage here on the 2O? The voltage against the voltage division, or you can just say if it's 5 volts. And then let's say if I call this whatever V1, then if you write the KVN, basically minus, I mean, even with I, you can say just this 5 volt and then 3 volt here, then therefore V1 is 2 volt, right? 2 plus 3 is 5. But just we can just also do KVL, so minus 5 plus V1 plus 3 equal to 0. So V1 equals to 5 minus 3, which is 2. Okay, so V1 is 2 volts. Okay, so we have voltage, and how about the current here? IO is for either of the resistors, we can say V over R. So V over R, which is, for example, 2 volt divided by 2 ohm, which is 1 amp. So the I is 1 amp. Okay, sounds good. On the other side also, we have the voltage. And how about IS? I have the IS. Okay, so IS is 5 over 2. Okay, very good. So based on this information, we can find the power for each of the elements and find the power. But one thing I would like to mention here, if you look at this connection here, basically what would be the current in this connection? If you see something like this, similar to this, that maybe there's one circuit here and there's another circuit here, and if there's just one line connecting them, just be assured that the I is always 0 here. The reason is that when the current goes to somewhere, there should be a path that the current goes out. Okay, so if there is not such a path, therefore the current would be 0. Okay, so we see something similar to this in other circuits that we use. So always the I would be 0 here. Again, when you have two different things, that there's only one path here, let's say if the current goes, but there's no way that the current can come back to the whole thing, right? If the current exit that, but there's no way that the current goes back because there's no connection. So the I is always 0. You can also see it from KCL here. So basically IS is looping through this. So the same IS is going here. So the I is 0. Okay, and then for the power, so we have the just basically voltage. So let me just do one of them. So this P is equal to, I can say just RI squared. Okay, R times I squared. The R is 3 ohm, the I is 1 amp squared. So it's 3 watt. So this is 3 watt. And then for this one, again, RI squared, 2 times 1 squared is 2 watt. 2 watt, 3 watts. For the 6 ohm, R 6 times I squared, 5/3 squared, which is 6 times 25 divided by 9, 50/3 watts. And as you see, all of them are positive because they're basically consuming the power. Resistors always consume power. But now let's look at the power for the sources. This power here. The power here is P equal to VR, P equal to VI, and but just check the basically polarity. So the V is 10, but then I expect the I goes here because of the passive sign convention, but the I is going the other way, so I have to put minus 5/3. Minus, oh, I'm not sure if you see what my screen is somehow wobbly. So this is negative because it's generating power. Okay, so now look at this voltage source. So the voltage is 5 times the I, which is going again from positive to negative, but the I is 1 amp there, so it's gonna be negative minus 5 watts. Okay, nice. So as you see, again, I don't know if you see my screen is wobbly. But anyway, 2 plus 2 plus 3, negative 5, cancel, plus 50/3 and negative 50/3. So there you have a power balance. Okay.